So here in these two examples, we're going to graph functions that are logs of some complex expression, but we're going to simplify the logarithms to get something simpler that we can actually graph using transformations of functions. So we're going to start with A. And for all of them, I'm going to start with finding their domain. So what's the domain? So remember that for a logarithm, like ln of x, okay, its domain is all positive values of x. In other words, I want the input here to be positive. So this means that here, this needs to be positive. But x squared is almost always positive, except when x is 0, in which case it gives me 0. So this function here is actually defined for all real numbers except 0. Okay? And maybe there's another thing I'd like you to notice, like maybe two things. Maybe we can look at the vertical asymptote. Vertical asymptote for ln of x is typically found where the input is 0, right? Because when x is 0, there's an asymptote for y equals ln of x. So I should expect that if the input here, x squared, can be equal to 0, this is where I'll find the asymptote, and it's equal to 0 when x is 0. So I should find also a vertical asymptote at x equals 0. Okay? And what else? One other thing I'd like you to notice is that this function that we have here is even. If I replace x by minus x, I get the exact same thing. So this means I'm dealing with an even function. So the cool part with even functions is that as soon as you have their graph on one side, you've got their graph on the other side because it's symmetrical. So we can just focus on their graph on the right-hand side over the vertical asymptote, and then we're going to just reflect it across the line, across the y-axis, and get the entire graph. So next thing is we're going to simplify our function using properties of logarithms, and one thing we can do here is send a 2 in front of the logarithm. So it makes it much simpler to graph it when we see it as 2 ln of x. Okay, ln of x is our toolkit function, and it's multiplied by 2, so we just know that this is going to be a vertical stretch of 2 of our toolkit function. So that's pretty interesting. So if I start with y equals ln of x, and I graph instead y equals 2 ln of x, so ln of x looks like this. Maybe let's keep track of the x-intercept. Now if I stretch, the x-intercept stays where it is, right? If I stretch vertically, it stays where it is because its y-coordinate is 0. But it's going to be a bit steeper because it's going to go a bit higher faster, like that. Okay? So this is still 1, 0. But remember that our function is even. So what I've drawn is only one part of it. Because if that would be my answer, it would be contradicting the fact that it's even, because now it doesn't look even. It's not symmetrical with respect to the y-axis. In addition, it would contradict this part, where my domain should be all reals except 0. So it should be also defined on the left-hand side of the vertical asymptote. And because it's symmetrical, okay, my curve, actually let me draw it in red, would be this. Has to be symmetrical. So this is what it would sort of look like. Let's take a look at B now. B, our function is ln of 1 over x minus 3. So first thing I want to do maybe is calculate the domain. Okay. So for the domain, two things must happen. I need to have 1 over x minus 3 positive, and I don't want to divide by 0, okay? But if that's positive, automatically x minus 3 is going to be different than 0. So the first condition, the first inequality just takes care of both. So if 1 over x minus 3 is greater than 0, well, 1 is positive, so that means that x minus 3 has to be greater than 0. So that means x is greater than 3. So my domain is everything above 3. Typically at this value here, okay, you'll find your vertical asymptote. Okay, but here it's not so obvious because at 3 the input is not 0, it's just undefined. So we'll see what happens with that as we graph our function. We'll see if x equals 3 turns out to be a vertical asymptote in the end. So first thing I'll do is I'll simplify this expression using properties of logarithms. Now 1 over x minus 3, that's log of a power of x minus 3. So I want to write it as a power, remember, because I've got this nice property which allows me to send the exponent in front of the log. And now it's much simpler because the x minus 3, now I recognize this as performing a shift of 3 to the right, and the minus sign in front just is going to perform a reflection across the y-axis. So this is going to reflect across the y-axis, I'm sorry, I said y, but the x-axis, our graph, and this will perform a shift of 3 to the right. So obviously I can shift and then reflect, or reflect and shift. Those will turn out, give me the same expression either way. So maybe I'll shift first and then reflect afterwards. But it doesn't matter. It could be 1 and 2. So so if I reflect, so this is y equals ln of x. If I reflect it across the x-axis, it will give me something like this. So this is y equals minus ln of x. Okay, and 1, 1 stays where it is. 1, 0 stays where it is. And then what I need to do is shift that 3 to the right. So the y-axis, which was my vertical asymptote, will now be x equals 3. So actually you see x equals 3 will be an asymptote. 1, 0 shifted 3 to the right will end up at 4, 0. And this is what the curve will look like. Okay, so you see it's not actually that hard. And this is indeed our function, right? If I replace x by x minus 3, it's really the function we wanted to graph.